When it comes to the derivative, we know that every differentiable function is continuous, so it cannot be differentiable also. When we have the functions in the form of exponential, so we can apply log on both sides. So this is the application of our log function. Since we need the answer in the form of tan theta by 2, so we can apply here half angle formula. In part E section, you will be having one 6-mark, one 4-mark question to attend. So where you have 2 questions on 6 mark from the chapter linear programming and the integration. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Here in this session, we are going to revise the chapter Continuity and Differentiability. Let's see the weightage of this chapter. So here from this chapter, in all the 5 sections, you will be having 2 multiple choice questions, 1 2-mark question, 2 3-mark question, 1 5-mark question and 1 4-mark question. Overall, you can expect 19 marks from this chapter. So basically, you can see the consideration of marks here is 19 and it is very important chapter also. So now let's take few objective type questions. The function f given by f of x equals modulus x minus 1 is continuous and differentiable at x is equal to 1, continuous but not differentiable at x is equal to 1, discontinuous but differentiable at x is equal to 1, discontinuous but not differentiable at x is equal to 1. So here we can clear f of x is equal to mod x minus 1 is actually a continuous function. Now since here we can see x minus 1 mod x minus 1 is greater than or equal to 0. So clearly we can write mod x minus 1 is also greater than 1. So now the limit of the function as well as the functional value of the function will be same here. So if you apply the limit as x tends to 1 for f of x and f of 1 value will be same. If you apply the limit, it is 1 minus 1, 0 and f of 1 is also 0. So clearly it is continuous and differentiable at x is equal to 1. Next. The greatest integer function defined by f of x is equal to greatest value of x is continuous but not differentiable at x is equal to 1, continuous and differentiable at x is equal to 1, discontinuous but differentiable at x is equal to 1, discontinuous and not differentiable at x is equal to 1. So if we see the greatest integer graph, so it is always like this. So it's discontinuous function, and when it comes to the derivative, we know that every differentiable function is continuous, so it cannot be differentiable also. So therefore it is discontinuous as well as not differentiable at x is equal to 1. Next. If y is equal to tan of 2x plus 3, then dy by dx is. So clearly it's a composite function. So we should apply chain rule here. Since we have tan here, we know that tan x is secant square x. So here it is secant square 2x plus 3. Next we need to derive 2x plus 3 also a linear function. So derivative of 2x is 2, derivative of 3 is 0 because it's a constant. So among the options here, 2 secant 2x plus 3, 2 secant square 2x plus 3, secant square 2x plus 3, secant 2x plus 3. So we can clearly see it is 2 into secant square 2x plus 3, option B. Next. If y is equal to cos root x, then dy by dx. Again, it's a composite function. We'll apply the chain rule. We have the options as sin root x, minus sin root x, sin root x by 2 root x, minus sin root x divided by 2 root x. We know that the derivative of cos is minus sin. So we will get here minus sin root x. Now again, if we derive root x, it is 1 by 2 root x. So the correct option is option D. Next one. If y is equal to sine of log x, then dy by dx is sine log x by x, cos log x by x, 1 by cos log x, 1 by sine log x. So sine of log x is cos of log x and derivative of log x is 1 by x. So cos of log x by x is the correct answer. That is option B. Now let's take 2 more questions. So here we have a function y plus sine y is equal to cos x, then dy by dx. So this is a function which contains both variables x and y. So this is an example of your implicit function. So when we are deriving y with respect to x, we have to write dy by dx. So therefore here, if we consider this function y plus sine y is equal to cos x, derivative of y is dy by dx. Derivative of sine y is cos y into dy by dx, and derivative of cos x is minus sine x. Now since we need here dy by dx, let's take common here. So we have dy by dx 1 plus cos y is equal to minus sine x. So dy by dx is equal to minus sine x divided by 1 plus cos y. Next question. If x square plus xy plus y square is equal to 100, then find dy by dx. So let's take this function. So derivative of x square is 2x. Since both x and y are variable, we need to apply the product rule here. So x into dy by dx plus y into 1. Derivative of x is 1. Derivative of y square is 2y dy by dx. Since 100 is a constant, the derivative becomes 0. Let's take dy by dx as a common factor. So 2x plus y plus dy by dx x plus 2y is equal to 0. So finally we'll get dy by dx is equal to minus of 2x plus y divided by x plus 2y. Next, if y is equal to cos inverse of 1 minus x square by 1 plus x square, x lies between 0 to 1, find dy by dx. So clearly it's an inverse trigonometric function. When we have to find out the derivative, let us simplify it first. Then y is equal to cos inverse of, in the place of x, I'll put x is equal to tan theta. Then theta will be equal to tan inverse x. So here we have 1 minus tan square theta divided by 1 plus tan square theta. 1 minus tan square theta, 1 plus tan square theta is cos 2 theta. So we will get cos inverse of cos 2 theta, which can be written as 2 theta. So we'll get y is equal to 2 theta, which can be written as tan inverse x here in the place of theta. So it is y is equal to 2 tan inverse x. Now we can find dy by dx. So dy by dx is equal to 2 into derivative of tan inverse x is 1 over 1 plus x square. So the answer is 2 by 1 plus x square. Next, if y is equal to x to the power sin x, then find dy by dx. So we have here the function in the form of an exponential. So when we have the functions in the form of exponential, so we can apply log on both sides. So this is the application of our log function. So here, instead of y is equal to x to the power sin x, by applying log on both sides, I'll get log y is equal to log x to the power sin x. And again, using the property of log function, that is log m power n can be written as n log m. So this can be written as sin x into log x. Now let us derive this. So log y is 1 by y dy by dx. On the right hand side, we need to apply the product rule because we have two functions. So first function into derivative of second, that is log is 1 by x, plus second function log derivative of sin is cos. So therefore we will get dy by dx is equal to, we can shift y here, y sin x by x plus log x into cos x. So which can also be written as y value is x to the power sin x, and here sin x by x plus log x into cos x. Now let's move on to the category of 3-mark question. If x is equal to a theta plus sin theta and y is equal to a 1 minus cos theta, prove that dy by dx is equal to tan theta by 2. So here both x and y are expressed in another parameter theta. So this is an example of your parametric function. So now while deriving parametric function, we always derive with respect to the parameter and then we will find out dy by dx. So here let's derive x with respect to theta. So dx by d theta is a, theta with respect to theta is 1, derivative of sin theta is cos theta. And similarly we will derive y with respect to theta. So we have a, derivative of 1 is 0, minus we have, so derivative of cos theta will become minus sin theta, so which becomes plus sin theta later. So now if we want dy by dx here, so we will divide dy by d theta divided by dx by d theta. So which is a sin theta divided by a 1 plus cos theta. We can cancel this. Since we need the answer in the form of tan theta by 2, so we can apply here half angle formula. So sin 2 theta can be written as 2 sin theta cos theta. So reducing it to half angle, we'll get this as 2 sin theta by 2 cos theta by 2. And here 1 plus cos theta can be written as 2 cos square theta by 2. So 1 cos get cancelled, sin by cos will become tan theta by 2. So hence we proved it. Next question, if x is equal to sin t and y is equal to cos 2t, then prove that dy by dx is equal to minus 4 sin t. So here the parameter is t. So let us derive this function with respect to t. So derivative of sin t can be written as cos t, and dy by dt, derivative of cos 2t is minus sin 2t, and derivative of 2t is 2. So now dy by dx is dy by dt whole divided by dx by dt. So which is minus 2 sin 2t divided by cos t. And again using multiple angle formula. So minus 2 sin 2t can be written as 2 sin t cos t whole divided by cos t. Cos t get cancels. Minus 2 into 2 becomes minus 4 sin t. Hence proved. Next question. If x is equal to square root of a to the power sin inverse t and y is equal to square root of a to the power cos inverse t, then prove that dy by dx is equal to minus y by x. So here the parameter is t. So let us derive them with respect to t. Now since dy by dx is dy by dt by dx by dt, so let me consider y first. I am deriving y with respect to t. So now here we have square root of a to the power cos inverse t. So root x means 1 by 2 root x. So therefore 1 by 2 root a to the power cos inverse t. Now a to the power cos inverse t is a to the power cos inverse t into log a, because derivative of a power x is a power x log a. Now again derivative of cos inverse t is minus 1 divided by root of 1 minus x square. Now let's take dx by dt. So again this is 1 by 2 root a sin inverse t into a sin inverse t into log a into 1 divided by root of 1 minus x square. So if I take dy by dx, this is dy by dt whole divided by dx by dt. So if we divide them, we can clearly see 1 by 2, 1 by 2 and log a minus 1 divided by root of 1 minus x square, root of 1 divided by root of 1 minus x square cancels. So we are only left with here minus a cos inverse t divided by root a cos inverse t whole divided by a sin inverse t divided by root of a sin inverse t. So if we have any function in the form of x by root x, then we can write it as root x because x is root x into root x. So here I can write this as minus square root of a cos inverse t and here a sin inverse t. So from the given question, root of a sin inverse t is nothing but x, root of a cos inverse t is nothing but y. So therefore this is minus y by x. Hence we proved it. Next question. Differentiate log to the power cos x with respect to x. So we have the exponential function. We'll use the logarithmic function on both sides. So let us consider y is equal to log x to the power cos x. So then here applying log on both sides, we'll get log y is equal to cos x into log of log x. Now we'll derive this. So here 1 by y dy by dx is equal to cos x into log of log x is 1 by log x and log x is 1 by x plus log of log x into derivative of cos is minus sin x. Now dy by dx is equal to y into cos x divided by x log x minus log of log x into sin x. So we can also replace back the value of y as log x to the power cos x. So this is the derivative of the given function. Next question. So we have 5-mark question. So we have 5-mark question basically from second order derivatives, that is finding dy by dx as well as d square y by dx. So the problems on second order derivatives are very important under the part D section. So we have few questions here. If y is equal to 3 cos of log x plus 4 sin of log x, show that x square y2 plus x y1 plus y is equal to 0. We know that y2 is nothing but d square y by dx square, that is the second order derivative. Y1 is the first order derivative dy by dx. So instead of dy by dx and d square y by dx square, we'll consider here y1 and y2. So now I'll derive this. So derivative of y is y1. So 3 cos of log x becomes minus sin of log x and log x is 1 by x. So next we have 4 sin of log x which becomes 4 cos of log x into 1 by x. Now to remove x on the right hand side, I'll multiply x throughout the equation. Then I'll get this as x y1 minus 3 sin log x plus 4 cos log x. Now again I'll derive this. On the left hand side we have two functions, that is x and y1. So let us apply the product rule. So first function, derivative of y1 is y2 plus second function is y1, derivative of x is 1. Now minus 3, let's derive sin of log x which becomes cos of log x and here plus 4 cos of log x is again minus sin of log x into 1 by x. So here also we have 1 by x So I'll shift again, or I'll multiply x again throughout the equation. When you multiply x here, this is x square y2 plus x y1. And I'll take minus as the common factor here, which becomes 3 cos log x plus 4 sin log x. So this entire function is nothing but our y, 3 cos of log x plus 4 sin of log x. So this can be written as minus y. Now shifting minus y to the left hand side, we will get x square y2 plus x y1 plus y equals 0. Second question. If y is equal to tan inverse x whole square, then show that x square plus 1 whole square y2 plus 2x x square plus 1 y1 is equal to 2. So now let us take this function. Again we have the first order and second order in the form of y1 and y2. So let's take y1, that is deriving with respect to x. Now any function in the form of square is reduced as 2x. For example, if you have x square, it is 2x. So therefore tan inverse x whole square can be reduced, or the derivative of tan inverse x whole square is 2 into tan inverse x. Now again we need to derive tan inverse x because it's a composite function. So 1 divided by 1 plus x square. Now denominator 1 plus x square I'll take to the left hand side. It becomes 1 plus x square into y1 is equal to 2 into tan inverse x. Now again I'll derive this with respect to x, but here we need to apply the product rule because we have two functions here. So 1 plus x square into y1. So 1 plus x square, derivative of y1 is y2 plus y1, derivative of 1 plus x square is 0 plus x square is 2x is equal to 2 into derivative of tan inverse x is 1 plus x square. Now again I'll multiply 1 plus x square throughout the equation. So 1 plus x square into 1 plus x square is 1 plus x square whole square y2 plus 2x multiplying 1 plus x square into y1 is equal to 2. So 1 plus x square cancels on the right hand side. So hence the equation is proved. So here 1 plus x square is same as x square plus 1. Now we have the last type of question from this chapter under part E section. So we have already discussed in part E section you will be having 1 6 mark, 1 4 mark question to attend. So where you have 2 questions on 6 mark from the chapter linear programming and the integration, and 4 mark question from determinants and continuity. So we have already discussed 4 mark questions under determinant. So we are discussing from continuity. So you need to just write either determinants or the continuity under the 4 mark questions. So now 4 mark question, basically you will get the question on continuous function. So we have few questions of this type now. Find the value of k so that the function f of x is equal to kx plus 1 if x is less than or equal to 5, 3x minus 5 if x is if x is greater than 5 at x is equal to 5 is a continuous function. So clearly they have given it's a continuous function, and by observing this we have the limits in this form, x less than or equal to 5 and x greater than 5. So that means we have both LHL, RHL. Therefore here since they have given it as continuous function, we have the left hand limit and the right hand limit is equal to the functional value at x is equal to 5, that is f of 5. Now left hand limit means x is less than 5. So if this is 5, so we can approach from left side, we can also approach from right side. So therefore this is LHL, that is x less than 5, and this is RHL, that is x greater than 5. Now when we are applying limit as x close to 5 from left side, the functional value that is x less than 5 is, then it is kx plus 1. And similarly when we are applying the limit as x close to 5 from the right side, that is x greater than 5, the function is 3x minus 5. And f of 5 means at x is equal to 5, the function is kx plus 1. That means x value is 5. So therefore it is 5k plus 1. Now applying the limits for both, we will get this as 5k plus 1 equals 3 into 5. So which is 15 minus 5 equals 5k plus 1. So by this we can clearly write 5k plus 1 is equal to 10. 5k is equal to 9 or k is equal to 9 divided by 5. So this is the value of k. Next question. Find the relationship between a and b so that the function f is defined by function f of x is equal to ax plus 1 if x is less than or equal to 3, bx plus 3 if x is greater than 3, is continuous at x is equal to 3. So clearly they have given it as continuous. So that means left hand limit as well as right hand limit as well as the functional value at 3 will be same. So now limit as x close to 3 from left side, that is x less than 3 means the function is ax plus 1. So limit as x close to 3 from the right side means x greater than 3, it is bx plus 3. And f of 3 means x is equal to 3. At x is equal to 3 value is ax plus 1. So x value should be 3. So this will be 3a plus 1. Now by applying the limits here, we will get here 3a plus 1, 3b plus 3, 3a plus 1. So on solving this, we'll get 3a plus 1, 3b plus 3 is equal to 3a is equal to 3b plus 2. Dividing by 3, we have a is equal to b plus 2 by 3. So this is the relation between a and b. Next question. Find the value of k if f of x is equal to k cos x divided by pi minus 2x if x is not equal to pi by 2. 3 if x is equal to pi by 2 is continuous at x is equal to pi by 2. So here x not equal to pi by 2 means either x is less than pi by 2 or x is greater than pi by 2. That means the left hand limit as well as the right hand limit is same. So therefore there is no need to write left hand limit as well as right hand limit. Now since the function is given as continuous, we can directly write limit as x close to pi by 2. The function is given as k cos x divided by pi minus 2x will be equal to the functional value at pi by 2. Now what is the functional value at pi by 2? That is equal to 3. That is f of pi by 2 is 3. Now to simplify here, I will take x is equal to some pi by 2 minus theta. So I am taking x is equal to pi by 2 minus theta. So since x is close to pi by 2, if I apply x as pi by 2 here, then theta tends to 0. So therefore limit changes to theta tends to 0. So limit theta tends to 0, k cos pi by 2 minus theta whole divided by pi minus 2 into pi by 2 minus theta is equal to 3. So limit theta tends to 0, k cos pi by 2 minus theta can be written as sin theta. And here we have pi. When you multiply 2 inside the function, 2 get cancelled, minus pi, minus into minus plus, 2 theta is equal to 3. So clearly pi and pi get cancels here. So we are left with limit theta tends to 0, k sin theta divided by 2 theta is equal to 3. K by 2 is a constant. We can write outside the limit. So k by 2 limit theta tends to 0 sin theta by theta. So this is one of the standard limit which we have studied earlier, whose value is equal to 1. So k by 2 into 1 is k by 2 itself. So therefore k is equal to 2 3s are 6. So the value of k is 6. So these are all the few important questions from this chapter. which I have taken to revise. So you can practice more questions from your exercises. I'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, and keep exploring. Thank you.